All right, so we are going to go over 3.7, which is called quadratic quandaries. Kind of fun to say. So quadratics, we're still in quadratics. Quandaries means like wondering, if you can think about that. So today you're going to be able to solve quadratic inequalities. Wait, what? So we've done quadratic equations, but now we're going to move on to inequalities, Ms. Johnson. Yeah. So there's an easy way to do it and an algebraic way to do it. That must mean graphically is easy, right, Ms. Johnson? Yes. Graphically is the more straightforward way to do it. And it actually makes sense. If you really think about it, it really does make sense. And algebraically. Algebraically, it also makes sense. It says interpret solutions to quadratic inequalities that arise from a context. So again, working with word problems. And these are the questions that you should be able to answer. You should be able to answer the question of how can we use our understanding of solving quadratic equations and graphing quadratic functions to solve quadratic inequalities? And what do our solutions mean in the context of a problem? And how do we identify and write all the solutions? Now, if you remember, the difference between an inequality and an equation is an equation has one answer or two answers, whatever, like x equals to 4. So x plus 10 equals to 12. You only have one answer, x is equal to 2, right? But in inequality, so if I said x plus 10 is less than 12, now I have a whole set of answers. Does that make sense? All right, so let's look at this context. So the context says, Carlos and Clarita have a brilliant idea for how they will earn money this summer. Since the community in which they live includes many high schools, a couple universities, and even some professional sports teams, it seems that everyone has a favorite team that they like to root for. In Carlos's and Clarita's neighborhood, these rivalries take on special meaning, since many of the neighbors support different teams. So they have observed that their neighbors often display handmade posters and other items to make their support of their favorite team known. The twins believe that they can get people in their neighborhood to buy their new project, painting team logos on curbs or driveways. So it says, for a small fee, Carlos and Clarita will paint the logo of a team on a neighbor's curb next to their house number. For a larger fee, the twins will paint a mascot on the driveway. Carlos and Clarita have designed stencils to make the painting easier, and they've priced the cost of supplies. They have also surveyed neighbors to get a sense of how many people in the community might be interested in purchasing their services. Okay. So surveys show that twins can sell 100 driveway mascots at a cost of $20, and they will sell 10 fewer mascots for each additional $5 they charge. Okay, so far so good. Okay, so that the twins estimate that the cost of supplies will be $250, and they would like to make $2,000 in profit from selling driveway mascots. Therefore, they will need to collect $2,250 in revenue. So revenue means the money that comes in. Oh, I'll explain that in just a second. Good question. This information led Carlos and Clarita to write and solve this equation. Boom. Okay. Someone asked in the chat, they said, hey, Ms. Johnson, what does it mean by 10 fewer mascots? So this is like a very econ way of explaining something. You'll learn econ as a 12th grader. But what happens is, can you all think about this? Like, if I said, okay, guys, I'm going to be selling, I don't know, muffins. Okay, I make really amazing muffins. You guys have no idea. And the flavor of the muffin sounds really funny, but it's really, really good. It's banana blueberry muffins. Actually, they're sourdough banana blueberry muffins. They're actually really good. I just made some and they're all gone already. Okay, so let's say I decide that I'm going to sell muffins in our class. And I say, okay, I think everybody would pay 50 cents for these muffins. They're smaller muffins. They're not gigantic. They're little. They're not like Costco size. They're like the regular size. So someone's like, yeah, 50 cents would be good. Now, what happens if I raise the price of the muffins? What happens to the number of people that would buy my muffins? Does it go up or does it go down? Yeah, it goes down. Why? Because for the same muffin, you want me to pay more Does that make sense? So, like think about it like this. When you go to the store and you see two things that are almost exactly the same, except one is like off brand and one is like name brand. So I don't know, think Kleenex tissue, for example. So Kleenex tissue box, let's just say it costs $2, but like, I don't know, the Walmart brand, it was like 89 cents. For the most part, people will buy the 89 cents tissue because it's not that big of a deal, right? It's tissue. But if it was something else, like say your phone, then brand kind of matters there. Does that make sense? So, but the more they charge, like now iPhones are ridiculous, right? They cost so much money that you'll notice that people will drop off because that's way too high for how much they pay. Does that make sense? So there's this idea that like, can you guys all pretend that this is like this here is number of people buying driveway mascots, and this is how much it costs. No, wait, no, we're the other way. This is how much it costs. This is the cost. And this is how many people would buy it. Well, over here at 0, everyone would want it, right? Like everyone, it's free. Wait, what? Not only the people that are like, no, I don't want you to ruin my driveway, they're not going to get it. So maybe like 10 people get it. But the moment that I start charging more, say like $5, now maybe one person drops off. Okay. And then maybe 10 people, if it costs $10, maybe like a couple more people drop off. So do you see kind of how like my function kind of looks like this-ish? So, which is saying the higher the price is, the more people buy or the less people buy? The higher the price is, the more people buy or the less people buy? Yeah, the less people. Now there's things that are like, there's a word for it. It's called inelastic. There are things that people buy regardless of price. Can you guys think of that? What is something that your family buys regardless of how much it costs? Yeah, food, water, gas, electricity, right? Eggs, exactly. It's the basics, right? So now let's talk about things that your family doesn't buy because the price went way up, right? Exactly. Plumbing, utilities, all that. So let's say, okay, so what happened? I'll ask you this question. Do you remember when gas got really, really expensive last year? What happened when gas got really expensive? What did you hear people saying more and more and more? I heard, whoa, that's way expensive. Yeah, exactly. Electric cars became a little bit more popular, right? Or even hybrid cars became a little bit more popular. Another thing that people started saying was, no, it's not worth driving that far because of how much gas costs, right? Yeah, people would drive less. Exactly. So there are things that are inelastic, like as in gas, but there's a limit that people will spend. So very good. So you guys all see that how this math plays into people's like driving and spending habits. Very good. Okay, so this part here is where I really wanted to get to. Good discussion, by the way. So this says solve this quadratic for x. Do you guys all remember how to do this? Solve this quadratic for x. Do you guys remember how to do this? It's a couple different ways. Yeah, I know you guys got some. Okay, so let me go over here to my lovely OneNote. Boom. So if you forgot, not a big deal. That's why we're here to remind you. Yeah, we have to do some switching around. Very good. Very good. Hold on a second. I lost something. Here it goes. Okay. So the first thing I need to get over here. Okay, let me make this a tad bigger. Okay, and then scoot this over. And then move this way. And then move this down. Okay, so what's happening here is that now we need to solve this equation. And there's a couple different ways that you can solve it. There's a couple different ways that you can solve it. So up here, I'm going to I'm going to focus on that. The first thing that I want to do is I want this side to equal to 0, but at the same time, this is a mess as well. So the very first thing I'm going to do is I'm going to multiply this stuff out. Yes, very good. You use the distributive property, exactly. So I'm going to use the box because that's my favorite. You guys all know that. So I'm going to use my box. So I got 100 minus 10x and 20 plus 5x. And some of you are saying, oh my gosh, Ms. Johnson, these are a little bit backwards. And it's not necessarily true that it's backwards. If you think about the context, it makes sense. This 100 is that 100 driveway mascots at a cost of $20. But then for every 10 fewer, they're getting $5 less. So this is an actual like cost that they're looking at, right? So I'm going to multiply this all out. I get 2,000. I get 200x. Oops, negative. I get 500x. And I get negative 50x squared. Can you guys all check my math, please? Because you know, Ms. Johnson. I think I'm good. Okay, so then I add all these together and I'm going to put it in standard form because that's the form I like. So I get negative 50x squared. I get plus 300x plus 2,000 equals 2,250. And that's this guy over here, right? Okay, so I told you I want this guy to be 0. I want him to be a 0. He's not a 0. So I'm going to make him be a 0. So the next thing I'm going to do is I'm going to subtract this off 2,250. So then I get, my answer is negative 50x squared plus 300x. And then what is that? Negative 250. You guys checking my math, right? Okay. So now I want to do something to this. I have options. I have factoring. I have completing the square. I have quadratic formula. What else? What other way do I have besides the ways that I just said? There's one more way that Ms. Johnson uses. I have factoring, completing the square, quadratic formula, and my best friend. Who's my best friend? Yeah, Desmos. Okay. So I am not going to use Desmos. Yeah. Yeah, you can use the quadratic formula. Someone else said that they used completing the square. So I am actually going to factor because that's my favorite way. That's the way that's my go-to. Okay. So what I'm going to do is I'm going to factor out this negative 50. Do you guys all see how there's a 50 here, a 50 here, and a 50 here? So I'm going to take out a negative 50. So if I take out negative 50, what am I left with? Let's see, x squared minus 6x plus 5 equals to 0. All right. I really like this. I really like this compared to this. I can factor this in my head. I can't factor this. So do you guys all remember factoring, right? So this is negative 50. And then this is Nathan's famous question, right? What two numbers multiply to get to 5, but add to get to negative 6? What two numbers multiply to get to 5, but add to get to negative 6? Yeah, right. I know. Very good. Someone's like, oh my gosh, I was right. Very good. So yeah, I got x minus 5 and x minus 1, which basically means x is equal to 5, x is equal to 1. Hey, Ms. Johnson, what did you do with this negative 50? Nothing, because negative 50 equals to 0 makes no sense. It doesn't make any sense. So I ignore him. Right? Not negative 2 and negative 3, right? Because negative 2 times negative 3 isn't 5. I need two numbers that multiply to get to 5, but then add to get to negative 6. Very good. Right? Okay, very good. So my answers are 5 and 1. Okay, so I solved that quadratic. And then what does that mean for x? What does it mean in terms of your story context? So it basically means this. So go back to here. So it says 100 minus 10x. Remember, this was the context. They will sell 10 fewer mascot for each additional $5 that they charge. So this goes down by $10. This goes down by 10 driveways for each additional $5 they charge. So any ideas on what it means? What does X is equal to 1 and X equals to 5 mean? Yeah, very good. Okay. So basically what it's saying is how many times are you going to lower you're either going to think about lowering the number of driveways you get based on how many upcharges you're going for. So 1 means if I raise it one set of $5, so now I'm charging $25. It means I'm getting 10 less driveways to paint, but I'm still getting that profit that I wanted, right? Which was, I'm still getting that $2,000, right? $2,000 profit. Ms. Johnson, it says 2,250. Yeah, but remember you had to spend $250 on there, so you had to make up for that. Another way you can think about this too is if I charge a lot more. If I charge 5 times 5, which is 25, plus the $20, if I charge $45 a driveway, but Ms. Johnson, you're going to get way less driveways to paint. Yeah, but because I'm charging more, I have to paint less, but I'm still getting the same amount. Does that make sense? So those are the two sets of price hikes that I can go with in order to still maintain my profit. Does that make sense? Yeah. Okay, so take a second and think about that. So if I say 1 is my answer, so that's going to be 1. So that's 5 times 1. So they're going to charge me. So this right here, if you think about this is how much I'm charging people to paint their driveways. This right here represents the number of driveways. Does that make sense? So the number of driveways times how much I'm charging gives me my profit. I know, seriously, you guys are so funny. I know. Okay, so I'm going to finish up really quick. It says, how would your solution change if the question they asked was, how much should we charge if we want to collect at least $2,250? Now, I don't know about you guys, but whenever I'm saving up for money, I don't necessarily think about, okay, when I get that enough money, I'm just going to stop. Like if I told you guys, hey, we're going to go, I don't know, somewhere. Let's go to Magic Mountain. We're going to go to Magic Mountain. I need you guys to bring some money. Make sure you bring, I don't know, maybe like $60. So like Nathan comes and he has $62 and am I going to be like, oh my gosh, no, you can't come with us. No, because $62 is he brought $60. So it's okay if you go over profit. So what does that mean, Miss Johnson? How are you going to change this? Well, instead of this equal to sign, I'm going to change it. But what am I going to change it to? So it's still going to say 100 minus 10x times 20 plus 5x. And I want, so it's either going to be less than or greater than. That's what you're thinking. Do I want the number of driveways times how much I want? Do I want it to be less than 2,250 or do I want it to be more than? Yeah, good. So I want it to be more than, because it's okay if I get more money than 2,250, right? Wait, hold on. Let me let that all come in. So this answer goes down here for number 3. Oh, I forgot that I know how to copy and paste. My bad. Okay, so it's going to be greater than. And why is it okay to be greater than? It's okay because guess what? It's okay if we collect more money. So last question, and then I'm going to pause you guys. It says, what about this question? How much should we charge if we want to maximize our revenue? Maximize our revenue. Huh. Maximize our revenue. What does that mean? So I'm going to turn over to my friend, right? But I'm actually going to graph this equation here because I have to have it solved for 0 so that I can actually do it. So I'm going to plug this equation into here and see what I get. Negative 50x squared plus 300x minus 250. Okay, so I'm going to look at this picture. And then it looks like 2 straight lines. So I'm going to zoom out just a little bit. Oh, it is a parabola. It's a very skinny parabola. Doesn't this make sense? What number here tells you that it should be a very skinny parabola? What number here tells you, oh, that's why it's so skinny? The negative 50, the 300, or the negative 50. So remember that this number here, now check it out. I'm just going to change this negative 50 to a 5. I'm going to erase the 0. Watch what happens to my parabola. Oh, he got fatter. You guys are like, Ms. Johnson, don't talk about parabolas like that. It's okay. They don't have feelings. We're okay. Okay. So what was the question again that they asked? They said something like, how much should we charge if we want to maximize our revenue? If we want to maximize our revenue. So does anybody see a maximum here? Does anybody see a maximum here? A maximum. Does anybody see it? Very good. Someone says, hey, Ms. Johnson, that the vertex is a max. Oh, the 3,200? Yeah, it's a max. Okay, so let me just write some stuff down so that you guys can understand, and then we'll call it a day. So my vertex is at 3,200. So what does that mean? It means x equals to 3, right? So let's go back up here. If x is equal to 3, let's go back up here. If x is equal to 3, oh, that means I need to upcharge $5, right? So how much would I be charging? Well, plug it in. Plug that 3 into there. How much would I be charging? Yeah, someone said it. Miss Johnson, you should be charging $20 plus $15, which is $35. Okay. So I'm going to move this for a second. So I wrote it down here, 20 plus 5 times 3. That's this guy, remember? Because this guy here is how much we are charging. So you should charge $35. Yeah, you should charge $35. And if I charge $35, how many people are going to buy it? So that would be 100. Oops, sorry, not there. That would be 100 minus 10 times 3. Oh, so 70, I'm going to have to paint 70 driveways. So then 70 times $35 is $2,450. Does that make sense? So in this context, the maximum was where our vertex was. Does everybody see our vertex up there? Okay. Hold on. Yeah. And then, so how many driveways would I have? Well, I was just going to plug it in here. So I got 70 driveways. Does that make sense? We're going to pause right here. We're going to continue on Friday.